Hi guys, today we're going to talk about finding the distance between 2 points. And so I just want to make sure you understanding that when we find the distance between these 2 points, all right, this on a square, the diagonal is not the same length as the horizontal or the vertical. Okay, so I could call this 1 unit and this 1 unit, but this would not be 1 unit. It's actually a little bit more than that. So we cannot just count how many squares it goes through. So we have to use another method. And so we're going to use the Pythagorean theorem. So we're looking at points 2, 2 and points 5, 6. And I'm going to show you a couple different ways to do it. Excuse me. The first way is to create a right triangle. So I can make a right triangle here, meaning we have a 90-degree angle. So make a horizontal and vertical line that connect the 2 points. And now that I've made the right triangle, I can see what the side lengths are. So in this case, I have 1, 2, 3. So this side is 3, and this one is 1, 2, 3, 4. Okay, so now we're going to use the Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. Whoops. And I'm going to just plug in the values. So a and b are interchangeable. And remember that c is always the side across from the right triangle. Okay, so we're looking for c. So a squared, that would be 3. I'm going to use the 3 for a and the 4 for b, and it would look like this. And 3 squared is 9, 4 squared is 16. And then we'd get 25. We'd add the 9 and 16 together to get 25 equals c squared. From there, I have to take the square root of each side, right? Because the square root and the square sign cancel each other. And we have c equals the square root of 25, which is 5. So this side length is 5. So that's how you could do that by making a right triangle. Now I'm going to show you another way to find the sides. So I can put my points right in a table, an XY table. So I have 0.22 and 5, 6. And I can just see how these are changing. From 2 to 5, it changed by 3. And from 2 to 6, it changes by 4. And that would be my A side length. And this would be my B side length. And then again, we're going to do A squared plus B squared equals C squared. So A, again, A is 3. So I'm going to do 3 squared plus B, which is 4 squared. And again, we'd follow the process. 3 squared is 9, 4 squared is 16. Remember, square means the number times itself. So 4 times 4 is 16, 3 times 3 is 9. And then we get 25 equals c squared. And I would take the square root of both sides, and c would equal 5. So that is 2 different ways to do it. The only thing I'm going to caution you is if you end up getting a negative sign, make sure that you don't put a side length of negative. It's not. Or if you do, it's negative 3 squared, which negative 3 squared would still be 9. But the side lengths, if you want to think about it, side lengths, we're talking distance. Distance will never be negative. You don't need to put a negative sign there. Okay, so let's do another problem just to make sure we're understanding. And we will use negatives this time, make it a little bit more difficult. Okay, so let's say we have this. We have this point, which is -2, -1. And this one, which is -6, -3. Okay, so I want to find this distance. So I'm going to first make my right triangle. So a vertical and a horizontal line that make the right triangle. Again, we're looking for this side length, which is C. And so I can count here. 1, 2, 3, 4. This one's 4. 1, 2. This one's 2. So I have A squared plus B squared equals C squared. And A and B are interchangeable. So I'll use 2 as A. So 2 squared. I'll use 4 as B. 4 squared equals c squared. Now I'm going to do the math. 2 squared, meaning 2 times 2. That's going to give me 4. And 4 squared, which is 4 times 4, will give me 16. And that looks like this. I'm going to add them together, and I get 20 equals c squared. To get to c, I have to take the square root of both sides. And the square root sign cancels out the square sign because they're opposite operations. And you have c equals the square root of 20. So square root of 20 is one that we have to put on a number line because it's not a perfect square. So I'm going to make a number line. And the two that I know that it comes between is the square root of 16 and the square root of 20. Oh, I'm sorry, the square root of 25. Whoops. Okay. And the square root of 20 is 5 away from 25 and 4 away from 16. So it's just a little before the halfway point. All right, because it's 4 away here, but 5 away here. So I would estimate that since the square root of 16 is 4 and the square root of 25 is 5, I would estimate that at 4.4 because it's just a little before the half. Okay, so I'm going to approximate that to be 4.4. All right, now I'm going to show you how we could do it using an XY table. So let's look at these numbers in an XY table. We have -2, -1, and -6, -3. So this is what I was talking about. If you go from -2 to -6, it actually goes down by 4. And from -1 to -3, it goes down by 2. So I can call this A, and I can call this B. So when I square them, I have -4 squared, okay, plus -2 squared equals c squared. And if I do -4 times -4, that gives me positive 16. And if I have -2 times -2, that gives me positive 4. So it looks like this. And when I add them together, I get the 20. Okay, and then I have to take the square root of both sides. And then we come right back up here where we're going to be doing the rounding. So you could do it either way, but you have to be paying attention that when you square a negative number, it's always positive. Okay, and that's how you would do finding distance between 2 points. And when we're using Pythagorean theorem, we can always make that right triangle.